Hi folks, now this is the third part of 3 regarding the terrestrial planets. And so we're going to be talking about Mars. So we've already talked about Mercury and Venus. And let me remind you how different those two entities are. And now we're going to talk about a third entity that is very different as well. Now I can't go further without mentioning, as this chart says, that Mars is caught up in a lot of curiosity and imagination driven stories that people have of Martians and Mars attacks and various movies like that. I suppose it all started way back in the late 19th century when people were starting to use telescopes. And this 8-inch telescope that is being discussed here is about the same size as what amateur astronomers have. In fact, an 8-inch scope is what I possess. I have a friend who gave it to me. It's really good to have gearheads as friends. You get their hand-me-downs. So anyway, I've not seen Mars look nearly this good. Perhaps at some point I will. But anyway, these drawings of this guy, who's Shepard Pally, created, sort of gave Will Percival, who created the Flagstaff Observatory, an idea that these were irrigation canals. And so the canals of Mars came about from that reason. And there have been other illusory type of pictures taken. And as you'll see, if we go from here over to here, this is the same region taken with a picture with more resolution. And in a similar sort of region where this was, where this picture was taken, we see things here that look like pyramids and skulls and that sort of thing. But these are erosion features. If you go to like Arches National Park, as I have, and you have a little bit too much to drink or smoke or something, or just very imaginative, you can see all sorts of things in anything you see. We find patterns in everything. So the last thing here is this crater, looks like a smiley face. All right, well, to each his own, I suppose. But I would suggest this as there's evidence to suggest that dust devils that we have seen through our robots that have landed on Mars, when we have dust devils go across, they create these patterns on the surface. So this could be those patterns that we see here. In general, these sorts of discolorations in the planet are due to planet-wide dust storms. I would have a tendency to believe science rather than one's imagination when it comes to this sort of thing. Details on Mars? Well, as we've seen previously, carbon dioxide is the prevalent atmospheric gas that we see in the terrestrial planets. Earth is different, mind you, because water has absorbed the carbon dioxide and has layered it in the ground. So that's the big difference. And this is the sort of atmosphere that we would see with Venus and we see with Mercury as well. But the amount of it is very much less, as evidenced by these numbers here. 1% of the Earth's atmosphere, and even much, much less when you compare it to Venus. The interesting thing about Venus is, at one time it did have an atmosphere. It did have water, so it must have had an atmosphere, because currently if you have liquid water on the surface, it would just boil away immediately. The air pressure is too low. But there is all sorts of evidence to show that water existed that liquid water existed on Mars. And I'll show you some of that in a little bit. But presently, we have detected frozen water ice in the polar regions. And with a telescope, as I should have put in a picture here, but in other, you can see these pictures as well. Look it up on Google or the internet or someplace. You can see the polar ice caps of Mars, and those polar ice caps you can see with a telescope, an 8-inch telescope, for example. And those ice caps are a surface layer of dry ice, frozen carbon dioxide, and then underneath that it could be water ice. And we've taken the Phoenix spacecraft and put that landed on one of the ice caps, and it detected water there, frozen. Okay, all right, so to continue on, the evolution of the Martian atmosphere. As you know, the evolution of the atmosphere is basically two effects: temperature and how heavy the molecule is. So carbon dioxide is a pretty heavy molecule compared to oxygen by itself, certainly hydrogen or helium, and also for water. Water is, dihydroxide, okay, H2O, and carbon dioxide is CO2. So CO2 is a very heavy molecule, and it being colder on Mars in comparison to Venus or Earth or Mercury, then the heavier molecules would stay put. Lighter molecules would escape very readily. Mars is a very small planet. Okay, and then this is what we've seen happen with Venus. As you get water molecules that get closer to the upper reaches, if you don't have an ozone layer or some other way to protect the ultraviolet radiation, then the water gets broken up and you lose the hydrogen, and creating a dry atmosphere. No way for you getting the carbon dioxide out of the atmosphere. Now let's go to the surface. The surface is where the interesting story about water occurs. So as with Venus, we have radar mappers of as well as visible observations of the planet. And we find that the southern hemisphere is heavily got lots of craters, as evidenced here. And we have this really deep basin here. And we have highlands up here with lots of craters. And then we have up here some craters. And we're looking at the northern region up here. And we have this very, very deep valley here, Valley Marineris. And we also have an indication of where various spacecraft had landed. Okay, there's all sorts of activity here. There's volcanism. There's a little bit of plate tectonics, and we can detect that here in this valley here. They're really not really plates. The reasoning here is that Mars just cooled off too quickly. But there's no real plates, but there was tectonic activity. Okay, so that means there's convection going on underneath that's trying to get that heat out to the surface. And the Olympus Mons volcano that you guys are pretty familiar with already is a good example of what's going on there. There's no real movement of the crust relative to the stuff underneath. And that is evidenced by how high Olympus Mons has gotten. This is Mauna Loa here. And Mauna Loa is the biggest volcano we have on the planet Earth, rising, as it says, 10 kilometers from the surface of the basin, from the seafloor basin. And Olympus Mons is, as it says, twice that. Now, on Earth, what we have is plate motion, And what is Mauna Loa and Mauna Kea now? That hot spot where the volcano was, where this volcano was created, that hot spot has moved. Okay, so the plate motion is going this way. And so currently this is where the hot spot in the mantle is, punching through the crust. But previously it was over here. Now Olympus Mons basically has been stationary for all this time, and that's why it is so much larger. Okay, so that's the basic reasoning why we don't see plate tectonics going on here. This actual crust is not really moving. All right. Okay. Now, other formations, we basically do have this, straining going on, and that's what I'm calling tectonic activity, because we do see evidence of faults, and we do see evidence of rift valleys, which is another telltale sign on the Earth that we have activity going on underneath. Okay, so this is the biggest evidence for that. And as little, if you wanted to play Trivial Pursuit, this thing is about 10 times bigger than the Grand Canyon. And if you've never gone to see the Grand Canyon, that is something that you should do. Walking down to the bottom and coming back up takes an entire day, but you don't understand the history of the Earth unless you do something like that. I forget how deep in history you go, but it is a very, very long time. All right. Now we're going to go and search for water on the planet. And basically, let me remind you that the atmospheric pressure and temperature is too low for you to find surface water now. But we have seen pictures that are very reminiscent of rivers on the surface, also craters here, but they look very, very similar to what we see on the Earth, and you can find your own pictures of such things, and I think most everybody would agree that there used to be running water on the planet. Okay, and on top of that, if you look on these radar images, then you see rivers, flowing through here, flowing through there, over here. Very interesting suggestions, if you will. Other things that are even more amazing are these things that are now, I realize, are called blueberries, but I've always used the word hematite for them. Hematites can only be formed underwater. So this is really good evidence that there was liquid water on the planet. There are other pictures that should give rise to believing that there used to be running water. Here is one here. And there are other ones that when a spacecraft has gone over a certain region, that a little while later, we see that there is a change in the surface characteristics, which we would, if we saw it on Earth, would be explained by water suddenly gushing forth and leaving a trail of sedimentary material. So that is essentially what we got in mind, and until we find any more evidence, there is this possibility of water there. And so that's the next thing that we hope to find on the planet is evidence for real life. Perhaps it's underneath in the permafrost. Perhaps there are some, if you will, fossilized remains. Okay, so the history of Mars is basically something that looks like this. Mars started off as a liquid planet like all the rest of them. It cooled off, it got a little bit of water, just like Venus and Earth. It would have been able to hold it less because it's so much less massive. The planet's interior would have cooled off very rapidly. And when it cooled off, the magnetic field that it would have generated would have gone away, thereby getting rid of one of the protective mechanisms that we have for our atmosphere, namely the solar wind, would now strip and erode the atmosphere, the upper atmosphere of Mars. And then finally, there was no way for, when that occurred, there was no ozone layer, and so the water would be stripped away because of the loss of hydrogen from the UV radiation. So all these things would get rid of the water, and we would be left without an atmosphere because of the solar wind. All right, so now we're left with no water on the planet, and basically open to the elements. And when you're open to the elements in space, it's basically you're going to create all sorts of impact craters, is what we see on the surface. All right, what is the evidence for impact craters? Well, Mars has got a couple of moons, which are more than likely just captured asteroids. But these guys, even though they're small, would have, could have hit the surface. These guys are about, a lot larger than the meteor crater or the meteor crater asteroid, right? That one was 100 meters across. But this is approximately the size of the one that took out the dinosaurs by landing in the Yucatan. So these guys would really do some damage to Mars. But it just shows you that that we do have this bombardment, and the solar system is still under construction, as the guys from the Planets movie would suggest. There's some imaginative people. You could perhaps, instead of putting people on Mars, you would put them on these asteroids. I don't think that that's a reasonable thing to do, but who am I to say? Anyway, topography of Mars looks something like this. A couple of deep ocean, deep basins. Here's Olympus Mons, highest volcano in all of the solar system. Here's the Valley Marineris, and here is where we've landed various spacecraft. Very interesting indeed. Here's some other pictures to remind you of some other science that's going on here. Another picture of all those blueberries around the heat shield rock. And then there's this rock that that we have pulled off of the Earth. I mean, this guy was found on Antarctica, and I'm not quite certain how they figure out this thing came from Mars. Now, it's very clear that if you have an impact strike on Mars, that you would throw out a bunch of material, and some of that material will land on Earth. I have no qualms about that. But how to determine that this meteorite came from Mars is something I'm going to have to look into, and maybe you can too. Perhaps that's an exercise for extra credit that you might want to be interested in. But in here, and things like it, you can actually resurrect perhaps fossils of bacteria and things like that. And that's where this goes to. So we'll end up talking about that later when we talk about life in the solar system. Okay, I think I talked about this earlier, where you visit a particular region at a particular time, and you look in the same region and you see a new deposit. So the thought is that between these 2 points in time, you had a water gusher, and it moved all this material down to here. So very, very, interesting suggestions of liquid water on Mars. And here's a picture of this fossil remains of bacterial life on Mars. Mind you, this is suggestive. It's possible, but the fossil remains are, I think, an order of about a couple orders of magnitude smaller than what we see on Earth for similar types of bacterial life. Namely, our Earth bacteria is 10 to 100 times bigger. So that's the end of it. This is the third part on Mars. So next time we'll be talking about the Jovian planets.